Good afternoon, dear students. Welcome to one more amazing session from Infinity Lane by Sri Chaitanya. How are you all? This is Suresh, Faculty of Chemistry from Infinity Lane. How are you doing? Hi, Shwansh. Great to see. Many students are there in today's weekend. So, welcome to NEET STEP UP 2025 program. In this NEET STEP UP program on YouTube platform, Infinity Learn offering you physics, chemistry and biology sessions right from 12 o'clock to evening 6 o'clock, and these sessions are absolutely free, and please use these sessions and get benefit of this. So by simply clicking the like button and share with your friends and subscribe to this NEET STEP UP 2025 YouTube channel. How are you, my dear students? Great to see that you guys are regularly attending the sessions. And today we are going to see the total organic chemistry, that is grade 11. We are going to take a quick recap of all the contents, right? Hi Shivansh, re-NEET के शीट गई है मेरा 608 मार्क्स आ गया, वेरी गुड. जफी वीडियो ऑन इलेक्ट्रोकेमिस्ट्री, अरे इलेक्ट्रोकेमिस्ट्री कल खत्म किया मैं, एक बार आप वीडियो रिप्ले देख सकते हैं ना. जफी एक सिंगल शॉट में कर चुका मैं, कल ही कर दिया मैं. You want one more? So I'll do one thing. All multiple choice questions from electrochemistry, I'll make a video in the next upcoming sessions, right? Is that fine? As far as the concept is concerned, you can go with all the concepts that are being given in the electrochemistry is done yesterday itself, right? From galvanic cell, electrolysis, and Nernst equation, Faraday's laws, batteries, corrosion, everything we did in the concept. And all formulas are made and simple tricks are also given in that. Thermodynamics, yes, thermodynamics, Monday, Tuesday, Wednesday. Next Monday, Tuesday, Wednesday. Thermodynamics का बना दिया मैं बना दिया, अब भी बना के आऊँगा, थंबनेल भी मिलेगा. हाँ, लाइक कर दो सब. And today's thumbnail is going to be what we learned so far in the organic chemistry. क्योंकि आगे organic chemistry और कुछ अच्छा करने के लिए अब जो भी अभी तक organic grade 11 का खत्म कर लिया मैं, सो एक बार क्विक रिवीजन के लिए एक अलग सेशन आज रखा हो आपको. Moment of force comes in physics beta, is not chemistry. Okay, so here in Infinity Learn NEET का आपका लिंक दिया, टेलीग्राम लिंक दिया, and also Google Forms also given. You can improve your program and improve your skills and improve your preparation and increase the best score, and you will get a better rank in NEET STEP UP 2025 program. And everything is given while late. So guys, you just make use of these sessions, right? So in Telegram channel link is also given. You all just go through that. So तैयार है? इशिता इज देयर, रिचा शर्मा, अभिनव. हाँ, स्टार्ट करेंगे हमारा सेशन का. हमारा ये प्लान है जो ऑर्गेनिक केमिस्ट्री ग्रेड 11 का. सो इन ग्रेड 11 वी डिस्कस अबाउट ऑल हाइड्रोकार्बन, सारा का सारा हाइड्रोकार्बन एक सेशन में 90 मिनट्स में आपको सामने रखाऊंगा, है ना. सो इन दैट वी डिस्कस alkane and alkene and a bit of alkyne also, and also we are going to discuss about the benzene and its special reactions. That's fine, we can go ahead with that. What late? So hundreds of students are still in the queue and jaldi. So everybody please attend the sessions on regular basis, on punctual basis, and the instructions given by me, you please use those instructions in your preparation time, and definitely you will be getting an excellent score in a NEET examination beta. So in that there is no hesitation, say that you will be getting very good score. And in these sessions we are going to give you the best out of best tricks, so that however the concept is so complicated, you will be getting a simple answer by simple method. So let's start about alkanes. In the alkanes, we just talk about alkanes. It is very simple. Alkanes. Let us talk about the preparation. CnH2n plus 2. Okay, let us see the quick method of preparation. First of all, how do you prepare alkanes? Alkanes can be easily prepared right from alkene or alkyne. So by simple hydrogenation, so you can use R, CH, double bond CH2. When you go for the hydrogenation in the presence of, you can use nickel, you can use platinum, you can use iron as a catalyst, or any metallic catalyst can be used, so that you are going to get an alkane or CH2 and CH3. फिर भी alkyne also can be used. Alkyne can also be used. In the same way, 2 moles of hydrogen इस्तेमाल किया जाएगा, so that you are going to get an alkane. So this is what you call it as a reduction. Again, when you prepare the organic chemistry, now properties of something can be a preparation of some other things. So that organic chemistry is such a simple thing. And this is one important method. And आगे आएगा, so alcohol से कर सकते हैं, and this is from alkene and this is from alkyne. You can prepare from alkyl halide. You can say alkyl halide. This is your alkyl halide. So the halogen can be chlorine, bromine, iodine. This can be subjected for reduction and you are going to get alkane. So this reduction, मेरा क्लास में ये खास बात है, ये reduction कैसा कर सकते हैं? What are the reagents that are used? We are going to, hi Abhinav, you are late today. So what are the reagents that can be used here? I am going to give you any reducing donors, like you can use zinc and acetic acid, you can use zinc and dilute HCl, you can use sodium in ethyl alcohol. Many reducing agents are there, or otherwise versatile reducing agent, lithium, aluminum, hydrate, what not, so many reducing agents can be used. As an acetic acid, okay. So this is from alkene, this is from alkyne, this is from alkyl halide. And also very important point, that is from carboxylic acid, that is decarboxylic acid, decarboxylation. So when you go for the decarboxylation, descending conversion में ये decarboxylation इस्तेमाल कर सकते हैं. कैसे इस्तेमाल कर सकते हैं? You can say CH3 and CH2 and COOH or COONA, when it is treated with sodium hydroxide plus calcium oxide, when you heat it, सोडियम हाइड्रोक्साइड कैल्शियम ऑक्साइड, ये मिक्सचर का आप क्या बोल सकते हैं? जल्दी बोलो, फटाफट बोलो. यस, इट इज सोडा लाइम. इसका नाम आ गया सोडा लाइम. So that what happens here, Na2, so this is removed, so that you are going to get a product CH3 and CH3. Side product आएगा Na2CO3. You can say complete organic chemistry में आ गया आज. And total 11th standard का बेटा, not total 12th standard का. I just want to take complete organic chemistry 11th and 12th as a marathon session about near about 6 hours. अब तैयार है? मैं एक सेशन करना चाहता हूं, अभी नहीं है, आगे सेशंस में. तैयार है बेटा? Are you ready for that? अभिनव? हाँ, एक माराथन सेशन. हाँ, 12th स्टैंडर्ड को 12th स्टैंडर्ड 11th स्टैंडर्ड के साथ, GOC के साथ, टोटल मोर देन 6 hours सेशन. If you are ready, I am ready. Okay, it's all depends on you. So this is what you call it as decarboxylation. In the decarboxylation you are going to get Na2CO3. So ये चीज में का इंपॉर्टेंट चीज क्या होता है? फर्स्ट ऑफ ऑल इसमें जो है 3 नंबर कार्बन था, अभी 2 नंबर कार्बन बन गया, सो दैट इट इज अ डिसेंडिंग कन्वर्शन. सो एक चीज है डिसेंडिंग कन्वर्शन का. सो डिसेंडिंग कन्वर्शन जो कन्वर्शन है, कार्बन एटम नंबर कम ही आ रहा है प्रोडक्ट्स में। एंड और एक चीज है डीकार्बोक्सिलेशन का रेट ऑफ डीकार्बोक्सिलेशन is directly proportional to stability of कार्बोनायन, जिसमें कार्बोनायन फॉर्म होगा। मैकेनिज्म नहीं बताना चाहता हूं मैं। जिसका कार्बोनायन ज्यादा स्टेबल है, उस कार्बोक्सिलिक एसिड एंड डेरिवेटिव्स आर गोइंग टू बी इजीली डीकार्बोक्सिलेटेड। दैट्स वेरी इंपॉर्टेंट। जब आप कार्बोक्सिलेशन डीकार्बोक्सिलेशन देखना चाहता हूं, ये पहला पॉइंट है, ये दूसरा पॉइंट है। और एल्स एसिडिक स्ट्रेंथ, और एक चीज है बीटा कीटो कार्बोक्सिलिक एसिड्स आर easily decarboxylated। बीटा कीटो carboxylic acids are easily decarboxylated। जिस नीट में किसी का और किसी क्वेश्चन निकालना चाहता हूं, ये तीनों पॉइंट्स का हिसाब से निकलेगा। Which of the following carboxylic acid is easily decarboxylated? A, B, C, D, मल्टीपल चॉइस क्वेश्चन। ये मल्टीपल चॉइस बीटा कीटो डीकार्बोक्सिलेशन ज्यादा होगा। इवन यू नीड नॉट हैव टू यूज सोडा लाइम, इतना जल्दी सिर्फ गर्मी करने तो हो जाएगा। और एल्स रेट ऑफ डीकार्बोक्सिलेशन एसिडिक स्ट्रेंथ निकाल के कर सकते हैं। आर यू गेटिंग और नॉट? एंड वेरी इंपॉर्टेंट डिसेंडिंग कन्वर्शन का वजह से। सो इफ यू कीप दीज थ्री थिंग्स इन योर माइंड, डीकार्बोक्सिलेशन it is used in this alkane preparation and properties of carboxylic acid. So that is how the organic chemistry is integrated, my dear students. एक बार thumbs up दे। If you like this concept, एक बार thumbs up दे। Yes. Rishant, अरे weak in chemistry reaction balance, how can I get improve this topic? Yes. अरे ऑर्गेनिक केमिस्ट्री अभी इसी वक्त में चल रहा है। ऑर्गेनिक केमिस्ट्री में बैलेंस करने की इतना जरूरत नहीं है, आप आराम से एक क्लास ले सकते हैं। एंड बैलेंसिंग करने के लिए हमारा जो चीज है रिडॉक्स रिएक्शंस बहुत इंपॉर्टेंट है। देयर आई एम गोइंग टू गिव यू द बेस्ट आउट ऑफ बेस्ट मेथड्स टू बैलेंस द केमिकल रिएक्शंस, स्पेशली फॉर द रिडॉक्स रिएक्शंस। वेरियस मेथड्स आर देयर, आई विल गिव द बेस्ट। ठीक है ऋषंत, इज दैट फाइन? ओके चलो आगे डीकार्बोक्सिलेशन के बाद सो वी विल बी डिस्कसिंग अबाउट द प्रॉपर्टीज ऑफ alkanes. So coal based electrolysis also you can do. So this is also kind of decarboxylation. Thank you very much, very good. Let's see. So we can see here are COOK or COOK, potassium salt of carboxylic acid is electrolyzed in its aqueous solutions, mean to say HOH, HOH. On electrolysis what happened? The products that are formed here, hydrogen is formed as a cathode, hydrogen formed at cathode, you can see it is formed at cathode, and this you can see as a K plus on OH minus, K plus OH minus is formed as KOH, and CO2 and CO2 decarboxylation takes place at anode plus 2 CO2, and फिर भी ये अल्काइल ग्रुप जो है ना, ये दोनों पकड़ के हायर alkanes are formed, higher alkanes are formed, and R, so these are formed at anode and this is formed at cathode. So in the NEET examination में the products formed in the coal based electrolysis at anode, at cathode, you need to identify. So I am giving you the concept and I am giving you in the NEET examination आपको कैसे multiple choice question निकलेगा. Got it बेटा? Fine. Is that clear? So try to enjoy. So this is actually a big concept, but I am giving in a simple सरल तरीका explanation. समझे? Okay, thank you Rishant. So don't worry, when you learn the concept like this, आपका balance भी निकल रहा है ना पर Rishant, है ना? Yes. Now let's talk about some more things, different types of strains. I just want to say conformations in organic chemistry you can see. Yes, conformation, isomerism is very important. You can see types of conformations. Let us talk about conformations. Whenever carbon to carbon single bond is there, whenever carbon to carbon double bond is there, whenever carbon to carbon single bond is there, the rotation about the carbon to carbon single bond is rotation is possible. Here rotation करना मना है, rotation is restricted. अगर रोटेशन पॉसिबल होगा तो क्या होगा, कन्फॉर्मेशन आइसोमेरिज्म आना है, रोटेशन रिस्ट्रिक्टेड है तो आपका ज्योमेट्रिकल आइसोमर्स आना है. सो कन्फॉर्मेशंस, सो यू हैव इक्लिप्स्ड, यू हैव स्टैगर्ड, you have skew conformation. Let us talk about what is this. Let me give you ethane as an example. Whenever ethane is taken as CH2, CH2, let us see here, eclipsed conformation, carbon and carbon. So two carbons are taken in a way, and this is the first carbon, this is the second carbon, and first carbon has two hydrogens and a group called X, and second carbon has two hydrogens and it is shown like this, and it has a Z. When X and Z on the same line, so that called eclipsed structure, and it is staggered structure. Staggered structure में क्या होगा? The same way you can rotate the carbon to carbon bond, hydrogen and hydrogen, X, and Z is going to be like this, Z is going to be like this, and X with hydrogen. That is what you call it as staggered conformation. It is completely opposite, is also called as anti. So dihedral angle is going to be here, it is a staggered and skew, and these are the structures. Eclipsed, you can fully eclipsed or you can have partially eclipsed. Where fully eclipsed, the bulky groups overlap with each other. This is the bulky group and this is the bulky group, let us say X and Y are the bulky groups. And partially eclipsed, ये वाला आपका eclipsed का जैसे देखता है, लेकिन bulky groups are not overlapping, लेकिन हाइड्रोजन के साथ overlapping कर रहे हैं, है ना? So they are in the same axis, that is called eclipse. Are you getting or not? Clear? Abhinav, come on, come on. So you kept quiet in the chat box, which is not permitted to you. So rocking strawberries. You qualified NEET examination. Congratulations. Congratulations. Now let's talk about this staggered होता है क्या? Two bulky groups are separated by 180. So this is what you call it anti, that is a type of staggered, and two bulky groups can be separated by 60 degrees. The जो थीटा है ना, ये दोनों का बीच में, ओके, दोनों का बीच में ये थीटा है ना, that is 60. Here it is going to be 60. Understand? Yes. Good. So those students who attended the previous classes and can have a short recap of all these things, so that आपका रिवीजन भी चल रहा है हमारा YouTube चैनल में, है ना? So मान लो ये सेशंस बहुत इंपॉर्टेंट है, सारे के सारे कॉन्सेप्ट आपको सीधा दे रहा हूँ एंड सिंपलीफाइड वर्जन में दे रहा हूँ. ये प्लीज ज्वाइन इन द टेलीग्राम चैनल दैट इज गिवन, सो दैट ये जो सेशंस का नोट्स आपको फ्री ऑफ कॉस्ट में पीडीएफ फॉर्मेट में मिलेगा, है ना बेटा? यस, वेरी गुड. एक बार everybody give a thumbs up and fire emoji in the session, so that we are going to rejuvenate with a lot of energy. So आगे बढ़े. Now this is what you conformations of ethane. Ethane, this front carbon and this is a back carbon. front carbon has 3 hydrogens, back carbon has 3 hydrogens. So this ethane, this is your front carbon, behind this rear carbon is there, the hydrogens of the front carbon, the hydrogens of the back carbon are maintaining the maximum distance, which is called as staggered conformation, whereas they are maintaining the minimum distance and they will be having more repulsion among them, that is what you call it eclipsed. So this is very important. ये important चीज का वजह से आपका नीट एग्जामिनेशन में क्वेश्चन आना का संभावना है बेटा. So here the basic fundamentals of the conformation isomerism here, torsional strain, eclipse is greater than staggered, and van der Waals repulsion, eclipse is more than staggered, and total repulsion, eclipse is greater than staggered, so that potential energy, eclipse is greater than staggered. So it is a universal fact, stability is inversely proportional to energy. So what happened, जिसका एनर्जी कम है उसका स्टेबिलिटी ज्यादा होगा. सो एक्लिप्स्ड का एनर्जी ज्यादा है, स्टेबिलिटी बहुत कम होगा. दैट इज अ फंडामेंटल रूल. You all follow this rule and you can get a very good question in the NEET examination. मान लो everybody has doubt in conformational isomerism. So many students are commenting. So और एक बार these concepts should be repeat करने के मांग रहे हैं. So that today I dare to take this time to provide this revision kind of thing in front of you. So you please get use of this. So you are attending the session, you are acquiring the knowledge. Also we are giving short recaptures in the middle of the weeks. So try to be aware of all the sessions. So कब revision होगा, कब कौन सा topic आना है. So NEET STEP UP 2025 YouTube चैनल है, एक बार सब्सक्राइब करो, ये बेल बटन दबाओ, so that आपका जो चीज आने वाला है एंड जो फ्यूचर का सेशंस आने वाले हैं आपका अपडेट मिल जाएगा, है ना बेटा. राइट. सो लेट्स टॉक अबाउट पोटेंशियल एनर्जी वर्सेस एंगल ऑफ स्ट्रेन. सो इक्लिप्स्ड का एनर्जी ज्यादा है, 60 डिग्री रोटेट करेगा, इसका स्टैगर्ड बन गया, और एक 60 करके इक्लिप्स्ड बन गया, और एक 60 करके स्टैगर्ड बन गया. सो दैट इक्लिप्स्ड स्टैगर्ड इट गिव्स लाइक दिस. सो एंगल ऑफ रोटेशन हर 60 डिग्री का बढ़ रहे हैं कम आ रहे हैं, बढ़ रहे हैं कम आ रहे हैं. सो दैट एनर्जी डिफरेंस बिटवीन स्टैगर्ड एंड इक्लिप्स्ड फॉर्म ऑफ ईथेन इज 12.55. सो दिस इज द एनर्जी गैप, दैट इज 12.55. That is experimentally calculated. You need not have to worry about that. Based on the data you can do it. So everybody can see me, can hear me, just give me a confirmation, because the chart seems to be a little frozen. So students are number is increasing but chart it is frozen. Somebody just give me a type over there. Come on. Can you able to see me? Can you able to hear me? Give me a round applause. Right. Rishant, Abhinav, Annamani is there. So there may be some glitch in the chart. Okay, there may be some glitch in the chart. Okay, let's talk about conformations of N-butane. So how do you say the N-butane? N-butane is CH3 and CH2 and CH2 and CH3. So by taking the second carbon and the third carbon, so the second carbon contains a methyl group and the third carbon contains a methyl group. So this is what you call it as a anti-conformation of the N-butane. So the methyl groups are in the opposite side, that is called anti. It is 180 degrees. है ना? Yes, it is. And if you rotate this front carbon and 60 degrees, it is going to be like this. So that a methyl group and hydrogen are eclipsed. So it is not completely eclipsed, it is a partially eclipsed. Yes, 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 yes. Kalki. Okay. Prachi, good afternoon. I am going to tell you this again. Kalki, just follow here. When hydrogen and the methyl groups are eclipsed. It is looks like eclipsed, but it is partially eclipsed. Whenever the methyl groups and hydrogen groups, methyl groups are maintained 60 degrees angle, that is what you call it as a Gaussian. So that is what you call it as a Gaussian. And when the methyl groups are in the same axis, that is what you call it is totally eclipsed or fully eclipsed. Yes, eyes proper nahi aa rahe hain isliye. Okay, now is my voice is properly audible, right? Is my voice is properly audible, Prachi? Give confirmation. Rishant, Kalki, right? And और एक 60 degree rotate करो. When the rotation happening in this one more 60 degrees, again you are going to get this structure like a Gaussian. So when two bulky groups are in the 60 degrees angle, that is going to be Gaussian. When the two bulky groups are in 180 degrees angle, that is going to be anti. So here when you look at these structures, anti is having the highest distance between farthest distance between two alkali, so two bulky groups, so that it is okay. Is my voice is audible now? Is my voice is audible? Is my voice is audible? Is my voice is audible? नेटवर्क इशू शायद मैं मेरा तरफ से एक बार क्रॉस चेक करना चाहता हूं. Is my voice is audible? Yes, network ठीक चल रहा है. Okay, let's go ahead. Not an issue. Right. So you check your voice from your side. So there is a network issue from your side. Our side, our technician is given confirmation. Our voice is perfectly okay. Right? That's good. So if at all you can rewatch these sessions once again. Yes. Okay. Thank you very much. So let's see. So it is having the distance more. So it is having the more stability, less energy. When it comes to the fully eclipsed, these two methyl groups जो देख रहा है ना, and they will have the more repulsion. More repulsion means highest energy and will have the least stability. That's what it is given here. So anti and partially eclipsed and Gaussian, and it is fully eclipsed, and it is going to be Gaussian again, and partially eclipsed, and it is going to be anti. Among them the stability, the potential energy in the order of, this is very important for NEET examination. So the potential energy order is going to be, सबसे potential energy of fully eclipsed is greater than partially eclipsed is greater than, and 1, and Gaussian is greater than anti. And you can say the stability and energy are inversely related. You can say stability इसका opposite आएगा, fully eclipsed, is less than partially eclipsed is less than Gaussian is less than anti. So anti का ज़्यादा से ज़्यादा stability होगा. Okay. Yes. It's very important. If you get a question from N-butane stability order NEET examination में, ये order का हिसाब से आपका आना है. It's very important. Clear? And let us talk about the physical properties of alkanes. So the boiling point increases as the number of carbon atoms increases. Okay, you learn first methane, ethane, propane, the gases, then liquids and solids. We don't memorize that kind of things. as number of carbon atoms increases boiling point increases. So the boiling point का values अब देखना के आपको पता चलेगा, methane -161, -88, -42, -0.5 like that, and of course they are the gases at the room temperature. Okay, so now one important point, the boiling point, the greater the branching the lower is the boiling point. A boiling point बोलने के लिए पहला जो चीज है, rule number 1, boiling point is directly proportional to molecular weight. I mean to say number of carbons. And rule number 2 कब इस्तेमाल करना? Boiling point inversely proportional to branching. So मैं क्या बोलना चाहता हूं यहां पर, if number of carbons are same, so ये चीज नीट एग्जामिनेशन में बहुत इंपॉर्टेंट है. नॉट ओनली alkanes, alkynes, alcohols, I means anywhere आप ये इस्तेमाल कर सकते हैं. Got it? If you talk about alcohols, hydrogen bonding का वजह से, and they have the higher boiling point than corresponding molecular weighted alkanes, है ना? So you need to follow the same kind of analogy for every chapter. So ये चीज बहुत important का कहीं भी इस्तेमाल कर सकते हैं. You can do anywhere. Okay. Now one more important thing, talking about melting point, ख्याल में रखो boiling point and melting point follows the same order, but यहाँ पर melting point जो है ना, it is having zigzag kind of pattern. So as molecular weight increases, melting point increases. Melting point is directly proportional to packing efficiency of the solid. If you can see here, this is the C1 and this is the C2 and this is the C3 and it is going to be C4 and C5. So you can see C7, C6 and C7. Now you can see C3, C5, C7 odd number वाला है ना, and C2, C4, C6 even number वाला having the greater melting point as compared to the corresponding next odd number वाला alkanes. That is very important. Very important. That is a pattern you need to understand. Ishita, fine? You came late now? Why? Ishita, you came late. Abhinav, this is very important. इतना सारा ग्राफ है ना, ये सिंपल ट्रिक का आपको दे दिया है ना. Now let us talk about solubility. Of course, alkanes are insoluble in water and they are soluble in non-polar solvents, and alkanes itself they are used as a solvents. Yes, it is clear. And Richa Sharma कहाँ? Richa दीदी कहाँ? Okay. So how is the weekend? After sessions, Monday to Saturday अच्छा तरफ सेशंस अटेंड करो सब लोग, एंड शाम तक प्रैक्टिस करो, एंड संडे पूरा छुट्टी ले लो, पूरा छुट्टी है. एंड ये नीट एग्जामिनेशन प्रिपरेशन का कम से कम 8 घंटा काम करना है, ज़्यादा से ज़्यादा 10 घंटा. ओके, डू वर्क इन अ स्मार्ट वे एंड यू कैन गेट द बेस्ट आउट ऑफ बेस्ट रिजल्ट्स, एंड डोंट डू लाइक ए बिग बुक बग्गर, राइट? सो स्मार्ट वे, and you just go ahead with your teacher's instructions and do the simple thing. You see the solubility and the chemical properties. So they are, alkanes are highly unreactive, therefore they are called as a paraffins. They are called as a paraffins. Para means less, Fin means reactivity. They have very less reactivity. Why? Because carbon is completely saturated. कार्बन सैचुरेशन की वजह से ये कम रिएक्शन होगा, एंड दे हैव द कंबस्टन रिएक्शंस. व्हेन एनी हाइड्रोकार्बन व्हेन combusted gives rise carbon dioxide and water and along with a lot of heat. Therefore, hydrocarbons, especially alkanes, are used as a fuels. है ना? So, mind it, when balancing the equation involved in complete combustion, it's a tip. आपको एक टिप दे रहा हूं बेटा, ये टिप पढ़ाओ एक बार, आपको पता चलेगा. So, complete combustion, remember every carbon in the original hydrocarbon gives one carbon dioxide and every two hydrogen atoms gives one water molecule. So, CH4, one CH4 gives rise 1 and 1 and 2 O2, so 2 hydrogens gives rise 2 H2O, so that it is balanced like this. This is a handy trick. This is very 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 important my dear students. So ये वाला जो चीज़ है आप नीट एग्जामिनेशन में ये बैलेंस करने के पूछ रहे हो. रिशन यू आर आस्किंग अबाउट बैलेंसिंग द रिएक्शन, यहाँ पे भी आ सकते हैं. एंड और एक चीज़ है इडियोमेट्री में भी ये इस्तेमाल कर सकते हैं, स्टोइकियोमेट्री में इस्तेमाल कर सकते हैं ट्रिप. ओके, वेरी गुड. सो वन मोर इंपॉर्टेंट थिंग, chlorination of methane. So as there are no reactions, so only free radical substitutions are permitted. In that chlorination of methane is taken. So chlorine and methane, so when chlorine react with methane react with chlorine, एक हाइड्रोजन मीथेन से रिप्लेस कर सकते हैं क्लोरीन के साथ, so that you are going to get methyl chloride. So क्लोरोमीथेन, और एक क्लोरीन है डाइक्लोरोमीथेन दे सकते हैं, और एक क्लोरीन है ट्राइक्लोरोमीथेन दे सकते हैं, एंड और एक क्लोरीन है टेट्रा का क्लोरोमीथेन. दिस इज व्हाट यू कॉल कार्बन टेट्रा क्लोराइड. एंड व्हाट डू यू कॉल दिस नेम इशिता, इसका नाम क्या, CHCl3 का नाम क्या, चार्ट बॉक्स में बताओ जल्दी, चार्ट बॉक्स में बताओ जल्दी. क्लोरोफॉर्म, दैट इज क्लोरोफॉर्म, एन एक्सेलेंट सॉल्वेंट. So when this reaction is taking place, this is a chain reaction. Yes, Raj, hi. So these mixture of compounds are going to get, why? Because it's a chain reaction. Got it? And you can see the mechanism is a completely free radical substitution. In this free radical substitution, you will be having initiation, propagation and termination steps. So in this, let us see the chain reaction. Okay, so initiation, chlorine is going to undergo homolytic cleavage like this. So the जो bond pair between chlorine से chlorine है ना, ये homolysis में chlorine free radical देता है. So 2Cl dot. So that is called radicals are created in the first step. In the propagation, जो chlorine free radical यहाँ पे generate किया, ये मीथेन के अटैक करके एक हाइड्रोजन निकाल के HCl बन गया, methyl free radicals are generated. Okay, that is propagation. And this reaction और एक बार करके आपका methyl chloride बन गया. So termination में फ्री रेडिकल मैकेनिज्म में हर बार ये 3 स्टेप्स होगा, इनिशिएशन, प्रोपेगेशन एंड टर्मिनेशन. हमारा जो टर्मिनेशन में जो फ्री रेडिकल्स ज्यादा बचा हुआ वो जोड़ी करके आपका न्यूट्रलाइज करेगा. सो Cl डॉट Cl2 एंड Cl डॉट CH3 Cl एंड CH3 डॉट gives rise C2H6. ये अजीब रिएक्शन है, ये अजब है ना. So a small amount of ethane is generated during chlorination of methane. Understand? That is an important point, you need to make a note of it. Got it? Clear? Fine. Now you can say one important thing, this is an overview. This is the overview. One important parameter I just want to say, reactivity of halogens. Reactivity of halogens. That is, fluorine is greater than, chlorine is greater than, bromine is greater than, and iodine. That is very important. और एक चीज है reactivity, एक हाइड्रोजन रिप्लेस कर रहे हैं ना, so that reactivity of hydrogen उसमें आपका टेरिशरी हाइड्रोजन ज्यादा रिएक्ट है सेकेंडरी हाइड्रोजन से और प्राइमरी हाइड्रोजन तक है. गॉट इट? नाउ आई जस्ट वांट टू गिव यू एन एग्जांपल. इफ यू क्लोरिनेट इन द प्रेजेंस ऑफ लाइट, क्या प्रोडक्ट्स मिलेगा? क्या क्या प्रोडक्ट्स मिलेगा? 2 मिथाइल ब्यूटेन, क्या क्या प्रोडक्ट्स मिलेगा? कितना प्रोडक्ट्स मिलेगा? नीट में क्वेश्चन निकलेगा. सो नीट में हाउ मेनी मोनोक्लोरो डेरिवेटिव्स आर फॉर्म्ड? क्वेश्चन, हाउ मेनी मोनोक्लोरो derivatives can be formed, including and excluding stereoisomers. The question may vary. That is a popular question. फिलहाल जो भी NEET और IIT or any kind of competitive examination में more than 10 times this question has been asked. Mind it, more than many times the question has been asked. Can you believe it? Yes, it is. So this is a simple trick. एक हाइड्रोजन निकाल के एक क्लोरीन लगाना है. So that this is one. So plain structures आप लिखना चाहता हूँ. ओके, यहाँ पर एक क्लोरीन है. ओके, एक क्लोरीन यहाँ पर लिखो, क्लोरीन, क्लोरीन यहाँ पर लिखो, यहाँ पर भी लिख सकते, लेकिन ये दोनों बराबर होगा. एंड और एक क्लोरीन है और मेरे साथ और एक स्ट्रक्चर होगा. सो कैसे होगा? देखो, आपका स्ट्रक्चर ऐसा है. नाउ देर आर 4 स्ट्रक्चरल मोनोक्लोरो डेरिवेटिव्स आर फॉर्म्ड. उसमें स्टीरियो केमिस्ट्री निकाल सकते हैं. देखो, कायरालिटी देखना है, जनरल ऑर्गेनिक केमिस्ट्री कनेक्ट करके ये वाला जो कायराल दिख रहे हैं मेरे को, बिकॉज दिस इज ए ग्रुप, दिस इज ए ग्रुप, दिस इज ए ग्रुप. यहां पर हाइड्रोजन मान लो, एंड दिस इज वन, दिस इज वन, यू कैन गेट इट, है ना. एंड 1 2 3 4 5 6 स्टीरियोआइसोमर्स, आई गॉट इट, है ना. और कुछ है, कुछ है, कुछ होना तो बोल सकते हैं आप. एंड ये कायरल नहीं होगा, ये कायरल नहीं होगा. अंडरस्टैंड? सो दैट वेन एवर यू कैन सी दिस कायरल सेंटर प्लस एंड माइनस होगा, एंड ए प्लस एंड माइनस होगा. टोटल 4 स्ट्रक्चरल आइसोमर्स, 6 स्टीरियो आइसोमर्स, इंक्लूडिंग स्टीरियो टोटल 6, excluding stereo only 4 structural. So like that questions in the NEET examination you can get it. Clear? So it could be any structure. आप खुद अभ्यास करना है बेटा. Understand? That's good to see. Good number of students over there, right? Very good. Ishita, no doubts? Ishita, come on, no doubts? Next, and oxidation. खाली आज alkane का हो रहा है. Students are continuously asking for repetition. No problem, we can extend these sessions in a split wise so that you can have alkenes a separate session and hydrocarbon benzene और a separate session. कोई प्रॉब्लम नहीं है. ओके, आज कितना तक हो सकते हैं तो उतना तक करना है, 3 बजे तक. ठीक है. नाउ ethane, when catalytic oxidation of alkanes, when you use a copper as a catalyst, you are going to get ethanol. When you use molybdenum trioxide, you are going to get acetaldehyde. Yes, हाँ, शिंक वाला. Okay, what is that? Hala Muhammad. And manganese acetate इस्तेमाल करो, acetic acid is formed as a product, है ना बेटा. So there are various products when oxidation happens with ethane with various catalyst, copper and manganese oxide and manganese acetate. different oxidation processes, different products are going to be getting. In the presence of copper, you got alcohol. In the presence of manganese oxide, you are going to get aldehyde. Manganese acetate, you are going to get ethanoic acid. Is that fine? Any doubt? Right. Now, one more. So, talking about alkanes is completed. Let's go into alkenes. Alkenes are CnH2n का है, ethene, propene, and ene double bond is there, and they have the planar carbon undergo sp2 hybridization, and it is a planar structure, and there is a sigma bond and a pi bond. ये pi bond की वजह से ये alkenes react होगा. They are also called olefins. So let's see the preparation of alkenes. Preparation of alkenes. फटाफट करना जल्द इतना. So dehydration of alcohols. You can see in the dehydration of alcohols. Alcohol is the compound with OH group. जो कार्बन एटम में OH ग्रुप है, OH ए अल्फा कार्बन बनना है, इसका बगल वाला जो कार्बन है बीटा कार्बन हो गया. सो OH फ्रॉम द वन कार्बन एंड hydrogen from the beta carbon are removed as a water molecule H2O, so that the bond is going to be made to between carbon to carbon bond. This is your alkene. So this reaction follows acid catalyzed dehydration. In this acid catalyzed dehydration, you can use ease of dehydration of tertiary alcohols is more than secondary alcohols is more than primary alcohol, because they are going to form more stable carbocation. So you can see concentrated H2SO4 near about 170-180 degrees centigrade is used as a catalyst, and you can also use H3PO4, you can also use Al2O3, okay, and you can also use P2O5 or P2O10, heating with POCl3, heating with KHSO4. So this is the age. We know H2SO4, but these 5 different chemical reagents can be used for dehydration reaction. Mind it. It's an extra edge I want to give you, can be used in the NEET examination. Okay? And let us see the mechanism. Let's see the mechanism. Let's see the mechanism. In this mechanism, you can get it. In this mechanism, you can get into dehydration mechanism. Water molecule is eliminated where carbocation is the product. The carbocation is intermediate. That intermediate can rearrange in the form, and this intermediate can give you the product. Okay. So let's see stability of alkenes. Before going for the stability of alkene, let us take a simple recap of the catalytic dehydration. So let's see CH3, CH2OH and heated with H2SO4, and it is going to get CH2 double bond CH2 by the loss of water molecule. So if you see the mechanism, CH3 and CH2OH, so the OH group that is present here, a poor leaving group, that is a poor leaving group, and this poor leaving group, and this gives you a protonated alcohol, so that the protonated alcohol can give you a better leaving group. You can see here CH3, CH2, OH2, and it is plus. This is protonated alcohol is a better leaving group. So this is lost. When this is lost, it is going to form a carbocation, and it is going to CH3 and CH2 plus. Now this carbocation formation is reversible, and it is a rate determining step. Ishita, fine. Now it is going to be, it is going to give loss of proton. It is a fast and product giving step. So this is how the simple mechanism of the dehydration you can take. You can take any kind of substrate and follow this 1, 2, 3 steps. That's it. If this carbocation has the ability to rearrange, it can rearrange. So that is how you need to manage. Otherwise you are going to say, sir, I am confused, I am going to into the stress and all. You don't go into the stress. Sir is giving 1, 2 and 3. You follow the same way. Got it? Now the time is not that great permitted. So what I can say, in the further sessions I can make various rearrangements and all. That is Wagner rearrangement, everything we are going to discuss it, right? So stability of alkene. So more substituted alkene is more stable. The stability of alkene is governed by hyperconjugation. In the general organic chemistry, hyperconjugation is already discussed. You want to just see the hyperconjugation process, you can go watch the replay. And in the general organic chemistry, ORAC multiple choice question, NEET tricks recapture, next Saturday I am planning. Okay, so you can join this next Saturday session so that you understand all kinds of GOC related tricks there, right? So certain questions I just want to make it, so you will be getting more advantage of it. Now more substituted alkene, यहाँ पर ये see 4 alkyl groups, yeah, you can see 3 alkyl groups. So more alkyl groups, more substituted, less alkyl group, less substituted, like that you can see, है ना? Now hyperconjugation is directly proportional to number of alpha hydrogens. So that is a simple trick that I can give you. Wherever the complex concept is there, this is the trick. More the substituted alkene, more is the hyperconjugation, more will be the stability. More substitution का वजह से more alpha hydrogens पे होगा ना. So more the alpha hydrogen is the key point. You can go ahead with that. So one more important thing, this is let मान लो ये isobutylene का है, ये transbutene का है, isobutylene is more stable, hyperconjugation का वजह से फिर. Now mechanism of dehydration that we already discussed. So rearrangement on the ring expansion also seen, and also see this is your ring expansion. How do we do that? Okay, if you see this simple printed format now, you may get confused, but I just want to give you one example here. Okay, so always मान लो कार्बोकैटायन का स्टेबिलिटी वजह से कार्बोकैटायन less stable carbocation has a tendency to rearrange itself to get it more stable carbocation. So this is the structure. This is the structure, you can see CH3, CH3 and CH3 and CH2 and CH3. Now make it here, it is an alcohol. Make it here, it is an alcohol. Now let us talk about dehydration. In the dehydration, H plus, so the lone pair of electron on the oxygen is going to be taken and it is going to take CH3, CH3 and CH3 and CH and CH. Now it is a protonated alcohol. This protonated alcohol is a better leaving group than the alcoholic group. So it is going to be like this. Now it is after dehydration, it is going to give corresponding carbocation. This corresponding carbocation, you can see. This is a secondary carbocation, beta. Secondary carbocation is less stable. So whenever less stable carbocation is there, it wanted to take a more stable carbocation. ये जो मिथाइल ग्रुप है ना, यहाँ पर माइग्रेट करने का बाद आपको टेरिशरी कार्बोकैटायन बन गया. सो यहाँ पर जगह नहीं है, यहां लिखना चाहता हूं मैं CH3 प्लस एंड CH3 ये ग्रुप माइग्रेट कर चुका है ना, इसी का कारण यहाँ पर मिथाइल ग्रुप बदल दिया मैं। फिलहाल सेकेंडरी कार्बोकैटायन था, अभी टर्शियरी कार्बोकैटायन बन चुका, ये मोर स्टेबल गया। So that this is going to lose a proton there. When a proton is lost, this proton निकल गया, so that you are going to see the H plus is lost. You can say you are going to see CH3 and double bond CH3 and CH3. So it is the stable major product होगा. Are you getting or not? Stable major product होगा. So this is the style you need to inculcate in the rearrangement system. So whenever the students are studying organic chemistry, यहाँ तक okay. Whenever rearrangement comes ना, you feel it is so difficult, but it is not difficult, my dear students. It is simple, less stable carbocation, more stable carbocation बनने का कोशिश करता. You can see H minus can migrate, CH3 minus can be migrate. So what is the order of migration effect? So you don't memorize that. You just make it and feel it which is more stable at the end. So more stable, more will be its formation. That is a simple. Whenever you learn in a simple way, you apply in a simple way. Whenever you learn in a complicated way, you will apply in a complicated way. Ab tak jayega. है ना? You all with me, right? You all with me, right? That's good. Now let's talk about the ring expansion, that you can say it's a Wagner rearrangement. You can say this one. Instead of this printed version, I just want to give you the normal version of this. Now this is a cyclobutyl and methanol. Whenever it is added with water, acid, the lone pair of electron present on this is going to attack this, so that protonated alcohol बन गया, CH2OH2 plus बन गया, ये वाला water is eliminated like this. OH2 plus is a better leaving group, so that H2O is lost. So what you are going to get here, it is CH2 plus बन गया. It's a primary carbocation. It's a less stable. Primary carbocation, less stable. समझ में रही क्या? Now what I mean to say here, this electron pair that is present is going to make a bond. So as a result of this, you can see carefully, you can see ring, 5-membered ring is less stable, 6-membered ring is more stable. So that you can see, right? This is the bond. I just want to make it here, so that this bond is broken, a carbocation is formed here. Now this is the bond. You can say there are 6 carbons, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. Are you getting or not? There are 6 carbons. So this 6 carbon, I just want to show you like this. The same, I just want to show you like this. So you can count it. 1, 2, 3, 4, 5, 6. 6 carbons आपका बन गया. Now this is going to be positive charge, and whenever it lose a proton, it is going to be a carbocation like this. It is a carbocation like this. Are you getting or not? So this is what you call ring expansion. This ring expansion, less number carbon ring is going to get more carbon ring. I just want to say 4 carbon ring can become 5 carbon ring. 5 carbon ring can become 6 carbon ring. 3 carbon ring do not. Okay. because cyclopropyl methyl carbocation is super stable due to dancing resonance, so that will not be rearranged. And 7-membered carbon can become 6-membered ring, that is a ring contraction because 6-membered ring is more stable due to bare strain theory. Got it? Clear? Yes, very good. Are Ishita, Hala Muhammad, you just see how many reactions that we are going to learn in the simple trick. Step 1, step 2 and step 3. But यहाँ पर ring expansion है ना, अगर ring expansion और rearrangement है तो और step 1 आ जाएगा, है ना? That's good, nice. And every week you can see. हाँ, इशिता और कुछ डाउट है ना तो बोलो, इशिता जल्दी. Very good. Now let's talk about preparation of alkene by partial reduction of alkynes that we know. You can see, I can give you the best reaction. CH3, CH, triple bond CH3. Now you just want to go with hydrogen in the presence of, you can use nickel, platinum, palladium, any catalyst you can use. It is complete reduction, complete hydrogenation. So that what happened here, you can see CH3 and CH2 and CH2 and CH3. N-butane is the product, alkane is the product. From alkyne you get alkane, but when you use incomplete partial one, it is a partial one. In that partial one, you can say partial reduction, partial hydrogenation. That can be done by using 2 different methods. So that is what you call it as partial hydrogenation. यह alkane में भी काम आ जाएगा रिएक्शन का. ओके, सो क्या क्या चीज इस्तेमाल कर सकते हैं यहाँ पर? यू कैन यूज PD and BaSO4 in the presence of quinoline as a solvent or isoquinoline as a solvent. अगर BaSO4 नहीं ही होगा तो CaCO3 इस्तेमाल कर सकते हैं. They can say it is a Lindlar catalyst or Rosenmund catalyst. Okay, organic, how many named reactions are there? Please, near about 25 named reactions are there. Kalki 11th standard and 12th standard मिलके. Okay, so जो भी नेम रिएक्शन है NCERT का ऊपर नहीं जाना है. Okay, near about 25 named reactions are there, right? From Sabatier-Sanderin, this is what you call Sabatier-Sanderin's reaction. Okay, and you can use nickel, sodium or lithium in the presence of liquid ammonia. In the presence of liquid ammonia, आपको क्या क्या products मिलना है? Whenever you use this, you are going to get CH3 and CH3 and hydrogen and hydrogen. cis alkene बन गया, cis alkene बन गया. When you say this, he is going to give you CH3 and C double bond C trans alkene बन गया. This is what you call bridge reduction, trans alkene. You can see from the same alkane you can get alkene and alkyne, alkane, है ना? Got it? Very good, nice. So this is the actual mind map. When you keep in your mind, like you can crack any type of question, my dear students. You just stay motivated. You know and you can do it. So I just simply want to say 25 lakhs of students are writing NEET examination, and what makes the difference between those students who write the NEET and who will get the rank in the NEET and who will not get the rank in the NEET? The simple definition, this is the crystal clear example. Learn in an organized way and a simple way and apply in that same simple way. That's it. If you just bombard yourself in your mind you will unnecessarily get a mental tension and you will be stressed. So hope you all are understanding. Kalki, Ishita and Hala Muhammad and Raj, how are you? Fine, doing great. Hope you are all understanding this, right? That's good. Now let's talk about from alkyl halides or haloarenes. Again, फिर भी ये called dehydrohalogenation. ये E1 भी हो सकते, E2 भी हो सकते. So this is the carbon and the carbon with the halogen that is called alpha carbon. And this carbon इसका बगल वाला है कि बीटा कार्बन, उसी से हाइड्रोजन निकालना है. एक हैलोजन एक कार्बन से निकलेगा, इसका बगल वालों का कार्बन में हाइड्रोजन निकलेगा. सो ये हाइड्रोजन एंड हैलोजन निकल रहे हैं. सो दिस इज व्हाट यू कॉल इट एज डीहाइड्रोहैलोजिनेशन. ये डीहाइड्रोहैलोजिनेशन करने के लिए आपका बेस इस्तेमाल करना है. ओके, सो दैट वेन एवर दिस एंड दिस इज रिमूव्ड, दोनों को बीच में एक अल्कीन आना है. दिस इज व्हाट यू कॉल इट एज डीहाइड्रोहैलोजिनेशन. समझ में आ रहा है क्या? Fine. So this you see, when you ready with this alkyl halide gives rise alkene, half of the alkyl halide is also completed 12th standard का पहला जो organic topic है. So plan in that way. Yes, plan in that way, you can rock. I am not joking. It's absolutely fine. You can do. When you follow the lectures like this, you are preparing alkene, you are studying the properties of alkyl halide. That is a smart way in preparation of NEET. So NEET preparation means रोज में 20 घंटा पढ़ाई करना, 4 घंटा सोते हैं. So you will get mad. Okay, study maximum of 8 hours. During examination time 10 hours, that's it. Okay, हर टॉपिक का, हर चैप्टर्स का, हर सब्जेक्ट का आपको ध्यान देना है ना. Yes, that is. You study in such a way that you can do the best. You believe in yourself and you fill your mind, heart with a lot of confidence, a lot of motivation. Okay, so that you are going to get the best. ठीक है? Now, so you can see आयोडोईथेन, ये अल्फा कार्बन एटम से आयोडीन निकल गया, ये बीटा कार्बन एटम से हाइड्रोजन निकल गया, ईथीन बन गया. It is also called as ethylene. Got it? That's good. And when you say 1 bromopropane, now bromine alpha carbon atom से and beta carbon atom से एक हाइड्रोजन निकल गया. So you're going to get propene, right? That's good. Now I'm going to present you a better rule, that is Saidgev rule. Yes, it is Saidgev rule. जहां पर एलिमिनेशन कर रहा है ना, ये Saidgev rule इस्तेमाल करो. Now when you see 1 chlorobutane, मान लो this is 1 chlorobutane है ना. So ये alpha है, okay, and ये beta है. So it is removed. So 1 but 1 ene is formed. No doubt about that. When you talk about this, CH3, CH2, CH3, यहाँ पर क्लोरीन है. That is 2 chloropropane. 2 chlorobutane. This is your 2 chlorobutane, my dear students. You see, I am going to explain you. This is an alpha carbon and इसका बगल वाला है बीटा कार्बन है. ये भी बीटा कार्बन होगा. Okay, don't go with IUPAC. It is alpha जो निकल रहा है, दो हैलोजन है ना, जो कार्बन अल्फा, इस तरफ एक बीटा कार्बन है, इस तरफ एक बीटा कार्बन है. जो बीटा कार्बन का पास हाइड्रोजन है ना, ये बीटा हाइड्रोजन है. ये बीटा कार्बन का पास हाइड्रोजन है ना, ये भी बीटा हाइड्रोजन है. सो आई जस्ट वांट टू शो ड्यूरिंग एलिमिनेशन व्हेन यू हीट इट विथ पोटेशियम हाइड्रोक्साइड, सो दैट अगर ये वाला निकल गया तो ओके, सो दैट you are going to see the product like this. You are going to see the product like this: CH3, CH2 and CH double bond CH2. And if you want to see, the product is formed like this. Okay, like this. If you want to see, this hydrogen is eliminated. I am going to see the product CH3 and CH double bond CH एंड CH3, दो तरीका प्रोडक्ट्स आपके सामने मिल गया. रतन वांट टू से समथिंग. नाउ उसमें कौन सा मेजर होगा? माय क्वेश्चन, which is major and which is minor? You tell me. This is but 1 in, this is but 2 in, this is going to be a major. So the major product and this is going to be automatically minor product. So major product is the one which is more formed. Why? Because ये Kirchhoff rule के हिसाब से. So जिस कार्बन एटम पर कम नंबर हाइड्रोजन है वहां से बीटा हाइड्रोजन निकालना है. Okay, right. So the carbon which bears the less number of hydrogens can remove its hydrogens and can form its corresponding alkenes. And also we can say during elimination the product that is formed is supposed to be more substituted alkene. That is what you call it as Kirchhoff rule, also called as Kirchhoff rule. Got it? It's an outstanding rule. You also you have to follow this Kirchhoff rule all the way. Okay. Opposite to that, you can get the product that is called Hoffman products. Okay. When you see Hoffman product Kirchhoff का opposite होता है. Yes, Kirchhoff का opposite कब आना है? Simple. Rule number 1. When the base is bulky, and the second one, when the leaving group is a poor leaving group, and the third point, thermal decomposition reactions. Thermal decomposition reactions. Actually, in the NEET examination, thermal decomposition reactions, hey nahi, so you need not have to get tension. But first point and second point are very important. Okay. So whenever Hoffman is coming, just keep these 2 points in the mind. Sir is giving the best tricks na, so that this tertiary butyl oxide is hindered base, a bulky base, so that it can't go into the molecule side, so that it takes the hydrogen that is available outside the molecule, so that you are going to get less substituted alkane. Yes, thermal decomposition means heat. Thermal decomposition means whenever compounds are heated to high temperature, it decomposes. Actually, tertiary amine salts or tertiary alkyl oxides, okay, tertiary amine oxides are heated, they are going to give the alkenes by Hoffman elimination. Actually those things are there in IIT. So I mentioned इसका NEET में सिर्फ 2 points काफ़ी है बोला. Ratan, you understand? Clear? That's good. Very nice to see. Very nice. Hope you understood all these things. Now we are almost about to wind up the session. Yes. And stay tuned. We are going to discuss some more stereochemical requirement E2 elimination. Their elimination group must be in transposition. I wanted to say here, I don't want to talk about this one. First, let us talk here. This is the one. This is the one. I just want to rewrite again. Okay, methyl group and hydrogen. Methyl group is there like this and hydrogen is there like this. And hydrogen is there like this and bromine is there like this. This is the better way to understand. Of course, when you heat with potassium hydroxide alcoholic or sodium hydroxide alcoholic or any kind of base, sodium ethoxide, okay, in ethanol, sodium methoxide in methanol, and potassium tertiary butoxide in tertiary butyl alcohol, many bases can be used. Okay, when you heat it, elimination, beta elimination is anti-elimination. Anti-elimination. Beta elimination is anti-elimination. So what is the meaning of this? this bromine, this is alpha, this is alpha, and this is a beta, है ना. सो जो ग्रुप लीविंग कर रहे हैं ना, इसका ऑपोजिट में ये वाला निकल जाएगा. अंडरस्टैंड? ओके. You can also say here one more hydrogen you can take, here one more hydrogen you can take, like this. This is your hydrogen and this is your hydrogen. Okay, ये hydrogen ये beta भी हो सकते हैं. So if there is a loss here, you are going to see the product like this. So that you can say a methyl group here and a double bond over here, and there is a loss between these two red marker bromine and hydrogen, you are going to get the product like this. You are going to see the formation of the, so among this is going to be the major. I just want to say anti, these two groups are going to be anti, this is an anti group, this is opposite to this stereochemistry. You got it? Very good. So this is going to be the major product. And as things goes on, we started somewhere at today class. We are about to close today's class. Everybody cheer up, Ishita and Ratan and Annabani. And I just want to say, today we started from hydrocarbon revision, alkanes and alkanes preparation we have seen. And the most important, we have seen the conformation, staggered, eclipsed, anti-Gaussian, and stability inversely proportional to the energy. And we have seen the chemical reaction, chlorination of methane, and in that initiation, propagation, termination. Also we have seen and more reaction, controlled oxidation. Then we stepped into the alkane, in that dehydration, formation of carbocation and rearrangement and ring expansions, and also we have seen dehydrohallucination, in that stereochemistry also seen. So actually I just want to feel that this kind of session with such a students like you, with a lot of efforts and with a lot of interest, want to come with the YouTube sessions. I want to run a marathon session for the total hydrocarbon 6-7 hours together. If you are ready, I am going to get it, because I want to feel it like you are bubbling with a lot of enthusiasm. I just want to give a lot of fire into that, so that we can rise and can give the best out of this. Now I just want to say, please like the sessions and share with your friends and subscribe to the NEET channel. And I am signing off here. Thank you very much. God bless you. We'll meet with more stuff, thermodynamics, in the next Monday's class. Thank you very much. Bye bye. See you. Signing off, Suresh from Infinity Learn. Bye bye.